everyone, welcome to another video in the Master Data Management in SQL series. My name is Elric, and today we will be creating clustered indexes for all of our tables, automating the process, similar to what we did in the last video with the defaults. And speaking of the last video, I had this in my head that I wanted to do something, but I completely forgot to do it. I probably make mistakes in every single one of my videos, and that is just development. You know, we try to test our code, but this live streaming development stuff is pretty difficult to keep it under a specific amount of time. So hopefully when you're watching it, you catch my errors, or leave a comment, tell me, so I can fix them. Probably create a small series where I just fix all my crap, like my comments and some of my variable equals variable in one of my videos, etc. But this specific mistake was a really big one, so I want to make sure that I change it now for you guys, because we will be putting more rows in this table. In the utility dataset datapoint default update, I had this as structure, and in my head I was thinking, man, I need to have one for default, one for clustered index, one for unique index, etc., etc. But it just didn't come out as I was developing. So please change that from structure to default, and then I'm going to head over to the relationship class family type and show you what I've done. Keep that one up. So the realm is still the same. Definition, the data point type. And the class is what has changed from structure to default, because I added another one for a clustered index. So the clustered index class is class ID 2. And then family, it's just the same record under a different class. A direct, and then type member. So that is my chain. Yeah, that is my chain. Default to data point type, clustered index, direct, member. And for the definition, we had already added, see, our class should just be data point type, and then we had already added the indexes, and then we had already added common for our definitions, for the indexes also, 2 being clustered. So I just went ahead and added another row for standard clustered indexes in my definition table under the data point type, clustered index, common taxonomy. Yep. So now, let's see, where's my data point type? That's my editing block. I'll just open data point type. So for data point type, I want specific data points in my system to be clustered across any table that we have. So what I did is I opened up my data point type table and found the specific data set number, the tenant, and the taxonomy ID. In this case it would be a family. But then I added the cluster ID, data point 25, and actually that's where my notes are. The cluster ID, which is data point 25, the implied specific data set number and implied foreign key, to be able to model my relationship tables. So sweet. Those will be my my clustered index fields. And then I was trying to speed this video up a little bit. I just went ahead and under this new type ID, and let me move this out of the way, I added those columns, those data point types under my new definition, and just put my data point type IDs. Essentially, I just copied this previous row, made a couple edits, and I was good to go. But there is a concept that I want to talk about that revolves around the specific data set number and the tenant ID, our 12 and 23. You can change these around. You can flip the order of them. And that is another thing that I did, is I have orders in multiples of 10, because if I want to, my unique index is going to have I'm going to have a unique index on the sequence. So if we want to flip them, we can actually make this 9. And we don't have to worry about 1, 2, 3, what's the max, make it the max number. It gives us room for mistakes. But the concept for physically modeling is, A, do you want to model everything on disk by table? So your tables are in specific pages and extents? Or do you want to model everything on disk by tenant? So your client's data is in one area and all the tables are also in that area, split apart. And then another client inhabits another set of pages, and so on. That is a decision for you to make based on your business. Do you deal with a lot of multi-tenant clients? Maybe tenant should be first. Are you really just a single type of business? Maybe it doesn't really matter. Tenants are good because we're going to use them to house templates for like building tables, but maybe it doesn't really matter. So maybe it's second. But this is my most preferred order, where it's really specific data set number, the tenant, the taxonomy ID, or the clustered group, depending on what you have. And then if you have any implied columns, implied data types, then we're going to tack those on. So the next step is actually to code, because my definition doesn't have a process type ID. And I'm going to close these. So how I like to code is actually just go to a table. You see, I did try to test this, but I didn't make it too far. And create a clustered index. Actually, we're going to do it a different way, because we want SQL to write our code for us. So I'm going to create a new index that will, what's going on? Is this one marked as clustered? No. I'll be damned. Oh wait, maybe I'm just not reading it right. Screw it. Screw it, we'll do it live. Oh no. I'm totally dropping the ball, sorry guys. There we go. Oh, my goodness. There we go. I was looking at the wrong option. Okay, back on track. CI prefix, clustered index, mark it as clustered, and make sure it's not unique. And then I'm going to add the columns that I'd like, which will be the specific data set number, the tenant. We are in the class, so there's only a cluster group, and we don't have the other fields, the other data points. And then I save it. So now I'm just going to script it as drop and create, because that writes our code for us. There's a really cool feature, you know, if we're doing it the right way, and that right way is our primary keys, our identities should not have clustered index on them, because that's horrible. We do not need a drop. There's actually an option in here, drop existing, and we're just going to turn that on. So we can change in our relationship the order and run this procedure again for the whole system or for specific data sets, because we're going to feed it a data set ID. And we don't need the drop. It'll just either create one or remove the previous one. So now I'm just gonna tokenize this script. This will be database name. Am I prepped for this? I think I could do that. This is the subject family name. And this is our data set name. And these will be our data points. Data point list. So that is my tokenized script. So, like I said, dataset ID is coming in. Let me make sure I'm actually on interface, so I'm using the right objects. Nope, mine's in too many places. There we go. No parameters here, just a base and an execute. Tokens with my dataset ID coming in, dataset name. Don't think I'll need a database. Doing it again. I don't think I'll need a database ID. I'm actually going to start using where-ins to minimize the imprint. So I could just use database name. Then I need to go. Let's see, based on my subject. So I believe, oh no. going to run here and pass in the data set. Okay. Okay, I think that's good. We will start with that and see if we need anything else. I'm going to go back to my dataset utility, or the default utility. I'm going to grab this relationship code. Actually, I'll grab that whole chunk. Initialize. I'll drop that down for you guys. Format it. And that will be our clustered index. And this guy is our base without the word go. Dataset ID. We're going to mark this as 1 for testing purposes, and then remove it when we create a store procedure, because we don't want a null value to trigger it, to trigger a rebuild on any table. So if I do, parent is the definition, so I will want I will want a definition ID in here. Essentially going to be doing the same thing. Replace system reference relationship with definition. Awesome. So I will get my common definition, and then let's see, we want to where in. All right. So because we took back information schema, we can go into the data point table, filter it by the incoming dataset ID, and the sequence will be on the outside, because we want to do it in the specific order. procedure. Get these two pieces. Just copy the where clause too then. Yep. For the most part. So we're gonna get the child row where the data point type ID is in the data points that we want. This will not give us an order. So we will have to reverse this. Join elimination. That's what just happened. There we go. So this data point type cursor. We're going to be modifying the tables that we are using, so we need to static forward only, read only. We're going to go in and we're going to get the list of data point type IDs that we need. So this will be our data point type ID, and essentially we need to do the same thing here. Is while we're in the cursor, we have to go back because we need the sequence in our build. We need to know the order of our cluster index because it makes all the difference. So we are going to go back into the data point and get the name and Nope. Dang it. Nope. Come on, Elric. You got this. Nope. I believe in you. Okay. This should grow. That's what I wanted to do. And not be empty. No, initialize. Initialize null variables or this. Ugh. Come on, up a little more. There we go. Ugh. There we go. Because if I the relationship table has two of the same data types, two foreign key implieds and two specific number or specific data set number implieds. I feel like I'm not prepared for this video. We'll nail it though, hopefully. There we go. So we got two of our implieds in one go and two of our children in one go. And that is why this is the technique to use when we know that, hey, we're going to have multiples in our data set. Multiple columns with the same type in our data set. Could we cursor through it and do a string here? You know, same kind of concept, but a cursor? Yes. Is it necessary? No. We want to build a specific string to replace in the center. And that is the only purpose of this cursor, to run through and build it. So when we are out of the cursor, all we need to do is trim the last character from it. Which will give us a neat list, no comma at the end, no errors. So that is the only thing this cursor is going to do. We need to get the proper order and then get things in the proper order. So outside of the cursor, since we have a dataset ID, we can get our dataset name. And our database name. Now, dataset name, point list, what we just created. Subject family and database name. So now we need the subject family. So we have our database name, and do I have a data set variable to store it in? Nope. Wait, data set abbreviation. Yes. I do. Get all these separated. Awesome. So, outside of the cursor, I need to trim up the name. So, I need the abbreviation. Not the abbreviation is the column. I'm going to rip something out of it. So I want to take the left 6. And the right 3. Yeah. And then should get the family name. Which should tell me what file this is going to go on. Now I have all of my replacement pieces to create my clustered index. Data set name, data point list, formatted at the very end, database name, and the subject family. This will allow me to have reference, relationship, realm, class, family, type on the reference data where it should go, reference cluster, but also when I get to that base relationship table or the base message or the base domain like group or people, it'll start separate my data to the other files like it's supposed to. Now, good times. Data set, database, subject, data point list. Start doing this instead of being surprised by errors. Good stuff. Wrong. I'm wondering if that option, drop existing on, will cause this to fail. That is unfortunate. No problems. I thought it would be easier, but that is okay. Just double up our code and fix that. Not double up, but okay. Okay. Database name. No prefix. We don't want to drop it. There we go. No probs. Use the database. Make sure it doesn't exist. If it doesn't, we're going to create it with drop existing off. And if it does, since we're consistent in how we are naming and doing things, then we are going to do it with its on. So you get the idea. That means, since we did it right here, we will just do select database name no prefix equals right side of the length minus db. And then add one more. Place database name no prefix. Let's see how that works. And that works. So that is what our code will be. Simple enough. Excellent. So I'm just going to take this, I'll modify this, index clustered, update. I'm going to get that dataset ID. We're going to delete all this code, place it, move that, create. Should create a blank cursor. Let's kind of leave it in my SQL. And then we're going to do the same thing. 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 We're going to run it for everybody. Once again, local static read only, forward only, because we will modify this table. Open. Snippet. Blank. Snippet. Cursor. Dataset. There. That will help me in speeding things up. I think Microsoft Snippet Manager is totally complicated for what it needs to be. I wish it would be way less complicated. Whatever. I do like Apex, but I feel like it slows down when I use it. Like, it's not as fast. The IntelliSense gets in the way of me using the snippets. I haven't tried DB Core yet. I love Redgate, but I don't know. Do not know. That is fair. Wow. Did not register. Did we get them all? Buddy. Most importantly, did they go to the right area? Yes, they did. Awesome. Now we have a... And now we're no longer dealing with heaps. We should get some speed increases. Fan-freaking-tastic. So this is our clustered index. I will be handling normal indexes or non-clustered indexes, unique indexes, this same way. And also making sure that if we have a foreign key in our table, that the foreign key exists in the same way, except when I do this, I'll just be looking up, you know, sys grp group ID. Alright, so that's TVL grp group. Are you in the same database? No? Alright, we can't make a foreign key. So, pretty good stuff. Now our next video is going to be on creating our first set of views, our actual first view. Because we have to stop talking to tables now and start talking to views. That is the goal. To select from views that are select only and delete from views that are delete only. And that will be the next two videos. We're going to add triggers to views that don't do anything except for raise an error. Like my delete view will have a raise error on insert or update. Or before insert or update, and vice versa. My select view will have a raise error on all three of them because we want to control how data is accessed. So after we get those views set up, then we can procedurally generate our CRUD procedures on top of that, minus the R, because I'm not going to select one row from a procedure. That seems time consuming and just doesn't make sense. But yeah, thank you very much for tuning in. We are on our way to speeding this up and getting into the core database. We just need some more tools, and that's what we will be creating. So thank you again. My name is Elric, and you have a good one.